There are 8 billion people on Earth. If we treat every person as a node in a massive graph, how many handshakes separate you from a total stranger on the other side of the planet? Surprisingly, the answer is usually just 6. This is the small world phenomenon. In a graph G with 8 billion vertices, the average path length L is counterintuitively small. For instance, on Facebook, this average distance is only 6.6. We live in a world of billions, yet we are all connected by a tiny handful of intermediaries. But why? Let's look at the math. To see why 6 degrees is so small, let's first imagine the opposite of a small world, a regular lattice. Picture 20 people arranged in a simple ring, where you only know your immediate neighbors. In graph theory, we call this the degree k equals 2. It's a world where connections are strictly local. To reach someone on the opposite side of this ring, you must pass through every neighbor in between. For 20 nodes, that's 10 steps. In this structure, the distance grows linearly with the population. Reaching a stranger requires a long, slow walk through a chain of intermediaries. Mathematically, the average distance L is roughly n divided by 2k. If we scale this to 8 billion people, where everyone has 100 local neighbors, the average distance is 40 million handshakes. The lattice math completely fails to explain our reality. Regular lattices have high clustering because your friends know each other, but the path length is massive. This local structure makes the world feel infinitely large. To shrink the world, we need to break the lattice. We need shortcuts. Now let us transform this rigid lattice. We start rewiring edges at random with a small probability p. Even if we only change 1 or 2 connections, we create shortcuts that span the entire ring. Think of these as wormholes. A single long-range edge does not just help the 2 people it connects. It acts as a bridge for their entire neighborhoods, slashing the average path length exponentially across the whole network. This is the magic of the Watts-Strogatz model. As the rewiring probability p increases slightly, the average path length L drops like a stone. Yet, the clustering coefficient c remains high. We get local structure and global reach. Whether it is international travel or the internet, these shortcuts make our massive world small. 8 billion nodes, yet only 6 handshakes away. The math proves it. We are closer than we think.